All right, ladies and gentlemen, not an incredibly long video today for several reasons. One of which is we just set this stuff up all yesterday, but I do have to make an adjustment right off the bat. There is no such thing as axis of symmetry in graphing a radical. I don't know how that got there, but that's all right. So what we're going to do, because this is not an incredibly long sheet, because I'm assuming some of you got to do some stuff from yesterday still. I might even jump in on one of those. But here, what I want to make perfectly clear is when you're working through these, let's play with 4 because it's got a little of everything in it. So first thing I notice, it's a square root. It's not a cubed root. So when things are square roots, you remember our little pattern here? All perfect squares. Okay? But there's a lot going on this time. Because this time, oh my gosh, what do we have working? We're going right 1. We're going down 5, this one. And we're going to be stretching vertically by 5. So here's the 2 ways that we talked about tackling it before. It is completely up to you how you want to do it. If you want to go full electronic mode on me, you can go into y equals. Let me make sure we're in the right vision here. Okay. So we can type in 5. Again, square root is just second in x squared. Or you can even hit math and do it that, but that I don't like that as much because it's not just a regular old square root. So let's get out of there. Okay, so oh my gosh, we're not in y equals. Hardy. Second in x squared. Hoofed up. Then remember, the minus 5 is outside. Whoop! Got to be outside. If you don't hit the right button, it's going to put it all under. That's not going to be any good. So I'm like, all right, so what's my deal? Find the error messages. And as soon as you get in after the error messages, those are the dots you want to start plotting. So we got 1, -5. And we just really want the whole numbers. 2, 0, 5, 5. That's going to be the easiest way. Okay? If you're like, well, I don't really like that much, Hardy. You know, what's my other option? My other option is any movement with left or right, we use X. So we're going to move each of these right 1. We're going to add 1 to each of these. And then both of the up or down and the stretches are Y's. So if there's a stretch, we're going to multiply by that number first. And then we're going to add or subtract the second part. So we're doing that with these. 0 times 5 is 0, minus 5 is -5. 1 times 5 is 5, minus 5 is 0. 2 times 5 is 10, minus 5 is 5. And I want you to notice something. 1 -5, 2 0, 5 5. That's pretty slick. So that's when there's a lot of things going on. But the thing to remember is your y's always adjust with these. X only adjusts with left and right. So we were asked to find domain and range as well. And we chatted about this too. If you look at that first point, okay, I'm at 1, -5 right here. Okay, that very first point that I plotted. Or I can even look at it this way. It's the very first point after my error messages start. That x value is where my domain starts. That y value is where my range starts. Everything has a pattern. Okay? That's the crazy one. Some of these other ones not going to be as bad. Now, as far as cubed roots go, you got to watch to see if there's a little 3 out there or not. I'm trying to see what I can get myself into here. Okay, I see another one to get myself into. Let's try out number 8. And again, I've got a key online, so if you need to check something, please check. So what if I want to put this in the calculator? All right, so we're going to go to y equals. This time I am going to use the math function. So math, you see there's a cubed root right there? That's the easiest way to go. So math number 4. There it is. But you're like, Hardy, there was something in front. Well, crap. I should have thought about that ahead of time. So -3, you get to see it again now, though. Math number 4, there it is. X minus 3. Looks just like that does. Now these, I pull up a chart. Hardy, there's no like error message this time. You're right. So I'm just going to take the values that they give me. I'm going to see, do I have any other that are going to fit? Oh, I do. -5. Yep, there we go. Do I have any if I go the other way? Ugh, that doesn't really fit though. So remember, these look like the snakes that are kind of slithering across your screen. Now, do you remember the other cool thing about these? I'll talk about the charts in a minute. Right 3 has to do with your x value. That -3, okay? Now, if you're looking at that, I mean, you can look at it as a -3, but that negative means it's going, it reflects. Because remember, most of the snakes were going this way up to the right. So if I'm doing it with the calculator, I'm good with this. And remember, the great thing about cubed roots is that they're always infinite, because the arrows go left and right forever, and they go bottom to top forever. And I would highly suggest, if you weren't here yesterday or you were in another world yesterday, that you go back and watch that video to kind of see how some of this stuff works. So here, when we're doing cubed roots, our parent graph is perfect cubes. We got that in your notes. That's where our starting point is. So right 3 means we're going to add 3 to all the x values. And that -3 stretch that we're going to be reflecting means we're going to multiply all the y values by -3. Again, let's check this out. 4, -3, 3, 0, 2, 3, -5, 6. Okay? That is going to be a short wrap on today. Again, if you need to, go back and check yesterday's out under classwork. Look at under lesson plans. Look under Monday. Or this might be a different year. Look in the day before that we were together. And check those out. And if you have other questions, I will be back with you next time.